Hey, greetings everyone. Daniel Lowrie here with Antisyphon Training, back with another series for you. This one is on networking fundamentals. That's right, we're going to try to learn you some good knowledge all about that networking business because it might intrigue you. You might be interested. You might have a home network of your own that you'd be like, you know what? Knowing a little bit about this might be beneficial to me. Or maybe you work on something like a help desk or a workstation support, and knowing more about networking could be extremely beneficial to you in your job role. Well, that's what this series is all about, to help you get up to speed, as it were, with the basics and the fundamentals of computer networks. That said, let's start off with, what is a network? What is networking? Well, networking is basically the enabling of electronic communication between devices. You got 2 things, 3 things, 9 things, a million things. You want them all to talk. You need to be able to move data and information from one thing to the other, regardless of what type of thing that is. As long as it's an electronic thing that can talk, I'd love to give it the ability to talk to other stuff. That's networking in a ball. And a network is the collection of those things. Maybe I own that network, maybe it's a large network, and that does bring us to a good point. There are different types of networks. Now, a lot of times you're going to hear just a handful of different types. You're going to hear things like a public network or a private network. Maybe you hear the terms LAN or WAN. Let's go down those roads really quickly. Let's start off with a public network. What is a public network? So a public network is anything that is open and accessible to the general public. Hence the name, right? Kind of fitting. Makes sense, right? There's very little to no security. It's fairly unregulated. Think of things like the internet. A lot of times the internet itself is referred to as the public network. Other public networks are things like Wi-Fi hotspots. You go to a coffee shop or something and they have an open wireless hotspot available. You can connect to it and access network connected things that way. Very, very cool. Now that is different than a private network. And what's interesting about it is, let's say you're in that coffee shop and you've connected to their Wi-Fi. They might also have a private network that you can't connect to. That's only for the employees. And that kind of helps you understand what a private network is, right? It is not publicly accessible. At least it's not supposed to be. If it is, we've got some work to do, right? Because now we want it to get back to be a private network, because private networks are not supposed to be publicly accessible. Only authorized personnel, that's who that's for. And you'll typically see a whole lot more security and guidance for how that can be accessed, what you can do when you're on it. So think of things like your home network, right? Business networks. Those are going to be your private networks because you have sensitive information on those networks you don't want other people to see. Not without permission anyway. Now let's go to LAN WAN kind of idea. LAN is a local area network. Right? That's a lot of fun to say, local area network, which is why we typically just say LAN. And that refers to the geographic location of your network. So if you're at home, all the devices that are networked together inside of your home that's your LAN. That's what that is. If you were at work, all of those devices that are connected inside of your work office or your work building. Maybe if it's a larger structure. It doesn't matter the size of it necessarily. What matters is that it is a self-contained geographical area, like your home, your office space, or your office building, and the networked things that are connected inside of it. That is your LAN. A little bit different than a WAN, and that's where you take LANs, a bunch of different little LANs all over the place. So let's say I've got an office in Miami. I've got another office in Chicago and another office in San Francisco, right? And I want to connect all those together. Well, they're geographically pretty disparate, right? They're far spread out. But there are ways to do that. There are ways to connect those things up. And ultimately, when those things make those connections, when those offices get connected, that is going to be defined as your WAN because they are geographically separated by a vast area. Now, that could be across the city, it could be across your county, across your state, but it could also be across your country, okay? So there you go. That is basically what is networking and what are the different types of networks that you might run into, as it were. Let's move on into hardware, though. Some things that you can put your hands on. That's right. You can go to the store, pick one of these things up, buy it. You probably have some of these objects sitting in your own home, enabling your networking capabilities. So let's start off with one of the most fundamental pieces, which is your network interface card. or Nick, right? Nick's a good guy. We like Nick. Nick's a friend of ours, right? Doing us a favor all the time. And now this could be a wired NIC, a wireless network interface card, or a wired or wireless NIC. We have both. But what does it do? What is it? It is the thing that gives us the ability to connect to the network, right? Now, a lot of times these are soldered into your motherboards, on your laptops, in your desktops, on your devices. So if you have a network-enabled device, it probably has a network jack connected to the motherboard itself, the board that it's running on. And on that is all the hardware necessary that is your network interface, also known as an adapter. I've got a USB adapter right here, though, right? I've got nice USB on one end, and I've got network interface on the other. So this is the NIC, and this is just the connector on how I attach it to a device, right? So we see you got a port, the wire cable club plugs into that thing, and we get some action, right? We plug this obviously in. Otherwise, it's just already soldered on. Maybe you have an expansion card that goes into an expansion slot, typically seen on desktops, maybe servers, things of that nature. So those are your NICs. They also have something very specific on there that I want to bring up, what's called a MAC address, MAC, the Media Access Controller. And what that is a very useful thing. It is a unique identifier for each one of these. So if I had 10 of these, they would all have a different MAC address. Let me show you what I'm talking about. Let's go to my computer here. I'm in a Windows 11 machine, and I have run this ipconfig/all command. And in here, we can see there's this physical address. And this right here is the physical address, also known as the MAC address. Yes, it does get a little confusing because there's about 10,000 different names that you can call your physical address, your MAC address, your burned-in address, right? It just keeps going down. The list is long and distinguished. But this is what you'll see here. You'll see all these different combinations of numbers and letters in what's called hexadecimal format, separated by either a dash or a colon. And you'll know that you have a MAC address because A, it says something like physical address or hardware address. And then you'll see that there are 6 sets of these alphanumeric characters. Okay? And that's what you're looking for. That's what you see. And then you know you've pretty much found your MAC address at that point. Not the only game in town, though. There's also a logical address. This is a physical address, right? It says it right there, physical address. This is something that's kind of tangible because it's actually burned into the cards. It's burned into the NICs. What's not burned into the NICs is the logical address, the IPv4 address. So we have the Internet Protocol version 4. There's also IPv6. That gets a little crazy, but it's just a bigger number and does a lot of, but basically does the same thing, right? So let's take a look at this IPv4 address, which is still very, 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 very common. More common than IPv6, I think. So we have what's called octets. So I've got this one, 192 separated by a period, 168 period, 1 period 5. And what's going on here is we've just got one side of this is the network I'm on, which is 192.168.1. And then I have the host portion, which is 5. It identifies this laptop as its own host. It's unique on this network. This is the network that it's on. This is the host that is on. Now, how do I know that that's the network it's on? That is a great question. You're a very smart person. And you can know that because of this subnet mask. It's masking off. You'll see the first, second, and third octets are masked off. That's what that 255 is. It says, basically, this should all be the same. And anything after that is what can be unique. It can be different, right? So that's what our subnet mask does. It basically tells our computer or our device, our host, what network they're on. And it looks to the IP address and goes, cool, I'm on the 192.168.1 network. And I am .5. So simple, right? It's not that hard. Subnetting is a different game. We're not going down that road, right? But here we have the mask that lets us know that that is the case. So if I had another device and it had a network address of 192.168.2, well, that would have to be the same as this according to this subnet mask, and therefore those two devices would not talk without some help. Okay? Those are two different networks, and the subnet mask is what informs the computer, the device, that that is the case. Very, very cool. All right. Last but not least, we see here and some information is the default gateway. And you can see that it has an IP address as well of 192.168.1.1. So it's on the 192.168.1 network with a host address of 1. And that is not atypical, right? Very, very common to see the gateway, which is the way that other devices get out of their own network. So we're on the 192.168.1 network. What if I wanted to go to 192.168.2 or .3 or .5 or .9 or whatever the case is? I would need to know how to get there. Your computer probably doesn't know that. The gateway, on the other hand, should know that. And if it doesn't, it knows how to find out. So the gateway, very important piece of the networking puzzle. And that's typically going to be your router, because that's the thing that connects to the internet or other networks, okay? So there we go. We've got that. Now, of course, this is all in Windows. I can jump over to Linux. You can see I've run the ifconfig command, not to be confused with the ipconfig command, right? And it gives us a lot of the same information. We have an IPv4 address. We have a net mask of 255.255.2.550, right? We see there's the Ethernet adapter address, right? The MAC address. It has one as well. You'll notice that that is also unique. But that's not the only way you can do this in Linux. This is actually becoming a deprecated command. This is kind of losing favor, as it were, in favor of the IPADDR command. That's kind of the new hotness that's out there for Linux networking. If I need to know things about it, like here is an adapter named ETH0, and it gives me the MAC address, shows me the IPv4 address, and very good. You can work with it and finagle with it. IP is extremely robust. It has a lot of functionality, so you can work with it and make you give it more or less information depending on what you need. But it's another just great tool. Just knowing IP adder, ADDR, is going to get you mostly where you need to go when it comes to troubleshooting, making sure things are working, and getting the right thing. Okay. All right, so we've been talking about NICs. We went down a long and winding road of all the things that are available when it comes to NICs. Let's go cables and connectors, right? Let's move on to that, because that's pretty exciting. Back to that idea of the hardware side of stuff, because although we were talking about NICs, which are hardware, kind of went into the software of things, how they work. Let's go with, a cable. This is a networking cable. You've probably seen one similar to this in your life. If you look around your office, your home, there are devices that might be connected with something exactly like this. Maybe a different color, but that's okay. There's just colors. And sometimes we use colors to help identify exactly what types of devices we're connecting with. But at the end of the day, what's going on inside this wire is probably the same. Now, this is a Cat5e cable. It has an RJ45 connector on the end. And I know all that stuff because, well, I know that an RJ45 connector is an 8-pin connector, which is kind of like a beefed up phone cable on one end, right? I can see that it has 8 wires inside of it for 8 pins. And RJ stands for registered jack. 45 is the interface standard that this cable uses, or the connector does, the connector uses. And Cat5e, I know this is Cat5e because if I look on the side, right there, it's printed on the cable itself. It says Cat5e, which gives me like about a gigabit per second bandwidth, which is pretty good. I like that. So these aren't very expensive. They typically come with anything that's a network device. So if you buy like a home router or Wi-Fi access point, that kind of stuff, a lot of times they just throw one of these in there with you because they're fairly inexpensive. Very economical choice. So this is what you see a lot of times. But if you need a little more horsepower, you need a little more oomph, a little more chutzpah, as it were, under the hood, well, you might want to go with Cat6, right? Gives you up to 10 gigs of data bandwidth. It's a little more expensive, right? But you get those higher speeds. And you get also less interference because it's much more shielded and protects you against crosstalk and interference. So that's cool. We like that. Let's move on. We've got some other parts of these things to go. Now, we looked at the adapter, right? This is the hardware. RJ45 connector right there. If you want to make a connection, you line the two things up. That only goes in one way. It kind of has a little castle look to it. You make sure that the tab is on the top, and you wait for the Chef's kiss right there, right? When it connects, it gives you a nice, very hearty click, letting you know that physical connection has been made. And then, of course, you'll want to go to the other end of the spectrum, your Wi-Fi router. That's what this is, a home Wi-Fi router. You'll look for the back for an RJ45 port. Make sure it's the right type of port that you're going to be connecting to. And you do the old, don't you just love, isn't that so satisfying to hear that click? So positive. It lets me know that is in there. It's not coming out. I have to push the tab and then I can remove it. But that's how you connect these things up. It's very straightforward, very simple. I like simple. I like easy. I hope you do too. Those things are out of the way. We also have Wi-Fi adapters. Now, this is an Alpha Networks Wi-Fi adapter. Notice it has like an antenna on it. Also has a MAC address printed on the back, right? Lots of fun. Normally, these, again, are soldered on the board. You don't see them. You don't see the antennas. This is more for doing professional networking stuff. Not that you can't do it with the stuff that's inside your laptop, but this is kind of more of a professional tool that I just happen to have because I do that kind of stuff. Very useful, but it gives you those access to those Wi-Fi networks, and you can then, network all day long. It's fun stuff. Okay, let's keep moving. Let me get this stuff out of my way. It's kind of cluttering up my desk here. Let's keep moving. What else do we got to talk about? Okay, we've been down the hardware road. I think now it's time to get a little more protocolish. If that's not where I like to contribute to the English language when I can. But protocols, the things that make these things work conceptually and practically, right? So let's start off with TCP. TCP is the Transmission Control Protocol. And it is what's called a connection-oriented protocol. It's very concerned with whether or not your data gets from point A to point B, and not just that it gets there in the right order, and that it has maintained its integrity, which we like. This is nice, right? So this is a protocol that helps transmit data from one device to the next so that you can have that conversation, right? This is what makes a lot of this stuff work. Without this protocol, many of these things would just, fail to launch kind of thing, right? So it checks for packet order, which is basically just little bits of data all wrapped up in an electronic packet that gets sent across, follows the TCP standard, and does what it's supposed to do and makes its way across the wire. Now, that said, when you create a TCP connection, you need to follow the rules. And the first thing you do, says the rules, is to do this three-way handshake. All TCP connections start off with this, and it starts off with this SYN or synchronized packet. So the originating device sends the SYN packet to the destination device. And when the destination device receives it, if it is on and ready to rock, it of course says, okay, I got you. I like this. I can talk to you, and sends a SYN-ACK packet back. So basically what you're seeing there is the SYN packet says, hey, can we talk? That'd be great. I would love to have a conversation with you. The SYN-ACK is kind of a response that says, I understand that you wish to talk. I would love to. I would love to talk with you. So once that goes back, so the synchronize and the acknowledgement packet hits back to the originating device. The originating device then returns the final bit of the three-way handshake, which, when it is done, establishes the connection and allows for data transfer, which is just another acknowledgement packet. Hey, thank you for being willing to talk to me. I acknowledge that I got your synchronization and acknowledgement packet. I'm ready to talk if you're ready to talk, and here comes the data. And the rules get set up, and the connection is established, and everybody's happy. So you've got SYN, SYN-ACK, ACK, or SYN, SYN, ACK, ACK, and then chop off the bookends and separate them. That's how I remember it. All right, so there's that. That's not the only game. Oh, you know what? I had a little treat for you. I'm going to show you what this actually looks like. It's not just theory, kids. Let's see here. Let's go to this Linux machine. And I use this tool called Wireshark. You do not need to understand this tool. You do not need to know how to use this tool. You do not need to know how to download it or get it installed or anything. It's just a tool that helps you be able to see network traffic. And I captured the three-way handshake with Wireshark. And what we can see is, if I move my slider over here, let's start at the beginning. We've got ourselves a source, and there's the IP address of the source host that started the conversation. And there's the destination host that it wishes to talk to. You can see the protocol is TCP. And then right over here, that first packet that was sent is a synchronized packet. Then we see a response from the destination host, which is now the source host because it's where it's coming from, back to our originating host, protocol TCP, and it sends a SYN ACK. And of course, as the three-way handshake dictates, you must then respond with the ACK packet. And of course, after that, I didn't have any data that I wished to transfer. I just killed the connection. And that is done with the reset packet that you see right there, that RST. But the three-way handshake right there, SYN, SYN-ACK, and ACK. Isn't that cool? Don't you love seeing that kind of stuff? Hopefully that makes it a little more tangible for you. And there you go. That's taking this diagram right here and turning it into reality, at least in the best way I possibly can. Not the only game, though. There are other protocols. One specifically that we want to take a look at, which is UDP, User Datagram Protocol. This is how a connection is made there. Your originating device right here basically pulls out its little data gun and fires at will at the destination, right? It just starts lobbing like a trebuchet these data packets over to the destination. It does not care. It is a connectionless protocol. It does not care whether it makes it. I mean, it cares, but it doesn't check. It's not like TCP where it's really like tied up in knots if it doesn't happen. It just goes bam, bam, bam. Here comes data. Enjoy. And of course, the originating, because it's using UDP as well, it does the same thing. It fires back. Oh, you wanted this data. Well, here it comes. And it starts dealing cards. So that's how that works. That's how UDP works. I just use the network time protocol as an example. And then the data that the network time protocol generated just gets sent back as fast as possible. Now, you're probably asking yourself, okay, Daniel, we got one protocol that seems to make sure that my packets get where they're supposed to go in the right order and that they are not messed up. But UDP just fires and forgets. Why would we use that? That is a really good question. Is that Elvis? No, I'm kidding. The answer to that is one is really good at data integrity and verifying things. The other is really good at speed, right? So TCP, great for this is what it should be, and I verified it. I make sure that it is that way. So email, web pages, stuff like that, you want TCP for. When it comes to UDP, I'm thinking of things like streaming video, streaming audio, video games, where latency, I need to keep down to a bare minimum. So if I lose a packet or 1,200 as the conversation goes, yeah, you'll get some voice artifacting or maybe some pixelation. You might drop a few frames on your video game. But at the end of the day, it does a pretty good job of catching most of the packets. So we make a trade-off. We don't get all the packets, we get most of the packets, and we get high speed. So UDP, great for speed, TCP, great for integrity, and making sure we get all of the packets and data that we want. Whew. That's a lot, right? Your brain's probably cooking at this point. We got one more thing I want to go over, right? And these are networking models. These networking models are what we use as frameworks, as standards for building network stuff, right? So if I want to build a router, if I want to build a NIC, and I want to actually be able to talk to other people that build routers and NICs and other networking devices, I got to follow the same playbook. I got to be on the same sheet of music as them, right? So what do? I follow the standard. Now, there's two I'm going to show you today. One is called the TCP IP model. This is a very practical model built on standard protocols. And then there's the OSI model, which is a 7-layer model. It's a more conceptual model. And you'll see the difference here momentarily. So let's jump in. Let's quit the jibber jabber. Let's get to it, right? So here's the TCP IP model. It's a 4-layer model, very simplistic. Like I said, very practical. Each one of these layers that you see here are built on standard protocols that we know and love, okay? So application, right? This is going to be your web browsing, your email, right? Your file transfer stuff. That's all going to live right here in the application layer. You have the transport layer. Fun. Manages reliable data transmission. That's what its purpose in life to do. Think TCP, right? That's our protocol that we love there. UDP also lives there as well. But it's because Transport is all about the fact that we're transporting data from one thing to the next. How do we handle that? That's all done at the transport layer. There are protocols in the transport layer like TCP and UDP. Then we have internet or network layer. This is the like IP lives here. This is where routing across different networks occurs. So if I have that 192.168.1 network over here, and I've got that 192.168.2 network over there, well, how do I get them to talk to each other? IP is going to help out with that because that's where routing consists and exists. Then we've got this access or link layer. This is the physical layer, right? This is where actually, like, I think MAC lives there, the MAC address, the physical address, right? It's physical, something physical. Wi-Fi lives there, your cables and connectors, your NICs, lions, tigers, and bears. Oh my. That's what goes on. So how we get connected physically into the network, that's going to live at that access layer. All right, so there's the TCP IP model. Remember, it's a practical model. And then you have this OSI model. This is a more conceptual model. It is of 7 layers, a bigger cake, as it were, right? We've got the application layer. Again, same kind of idea as before. But then we have presentation and session. All right, we've added a little bit here. What's going on? Well, presentation, what format are we using to show the data? Is it an image? So we're using like GIFs and JPEGs and things of that nature? Is it text? Is it just random strings of characters and text, right? A, B, C, D, E, F, G, 1, 2, 3, 4, 5, special characters, so on and so forth, ASCII text. Is it sound? Yeah, that kind of stuff. How is the data going to be presented? And you have the session, which is, hey, I'm going to be concerned with the building up, the maintaining, and the tearing down of sessions connections, right? The network connections as they get made. The session layer kind of dictates how that works. Now, you can use any protocol, anything on these layers that you wish, right? They're more of a guideline than an actual hard and fast rule, but what should be going on at each one can kind of help you out with troubleshooting or things of that nature, right? We've got transport layer. That looks pretty familiar. We've got network layer, right? That's going to be the IP, the routing portion. We've got data link. That's where MAC lives, which is a little bit above the physical layer, and the OSI, which is more about, can I put my hands on it? Does it have an electrical signal? The data link layer is really concerned with MAC addresses and things of that nature. But so that's kind of the difference that you'll see between it and TCP. It kind of teases things out a little bit more and gives you not such a hard and fast necessarily rule on how those things go. So there's your 2 models of how we build networking things and how we make networking works and make sure that everybody that is doing networking does it similarly so that everything works. That's what we like. Everything working, because it is not fun when things do not work. Which is why we're going to have a whole troubleshooting episode in this series. So be on the lookout for that. That said, there are more episodes coming in this series. So be on the lookout. Make sure you hit the like and subscribe, right? And then your notification bell so that you get notified when those episodes come out. And you can watch them and enjoy them. Hopefully they're super helpful to you and you gain a little more insight to how networking works. That said, this was a lot of fun. Make sure you follow Antisyphon Training at antisyphontraining.com. Join us on Discord. We got a lot of stuff going on throughout the week. Tons of live stuff. So hop on in, join us. We'd love to see you there. Until next time though, kids, have a great day and I'll see you in the next episode.